with section 1.1, inductive and deductive reasoning. So in this section, you will learn about inductive and deductive reasoning, counterexamples, and patterns. So let's recall some order of operations. So PEMDAS, parentheses, exponents, multiply and divide, add and subtract. So for multiply and divide, you want to go from left to right. Add and subtract, you want to go from left to right. We also have the distributive property if we need that. So if we were to do this, we want to do parentheses first. So we want to simplify that. I'm going to rewrite it. 3 plus 15 is 18. Okay. So now that parentheses, we don't even need it anymore. So we can rewrite it without it. Now we just have an add and subtract problem. So we're going to go from left to right. So we'll start here. Negative 9 plus 40 is 31. Minus 18 is 13. And you can use a calculator to do this as well. So negative 9 plus 40 minus parentheses 3 plus 15. This is a TI-84 course. So that is the answer. All right, the next one. Let's go ahead and look at it. It says parentheses first. So we want to do the 20 minus 4. So we have 2 plus 6 times 20 minus 4 is 20. So we don't have any exponents. We have multiply. When there's no operation between them, it's automatic multiply. So we have 2 plus 2 times 20 is 120. So we add those up and we get 122. Right, so let's keep on going. Evaluate an expression. So whenever you have a problem where it says evaluate the expression for x equals some number, you're going to replace the variable in the expression with a number and then find the value of the expression. So instead of writing x, I'm going to substitute in a 2 here and a 2 here, and that's a multiply. So I can do 8 times 2 is 16 plus 12 over 2 times 2 is 4. We're going to simplify the top and bottom separately. So 16 plus 12 is 28. Divide by 4. This is a fraction, but it also can be represented as 28 or said as 28 divided by 4, which gives us 7. That is our solution. Let's go to the next page. We have some definitions we need to learn. So inductive reasoning, a process of arriving at a general conclusion based on observations of specific examples. So inductive, it is a type of reasoning that involves drawing a general conclusion from a set of specific observations. So I could say, this class is cold, so effectively, this class is always cold. Conjecture hypothesis, the conclusion formed as a result of inductive reasoning, which may or may not be true. Counterexample, a case which the conjecture is not true, which proves that conjecture is false. So that's a counterexample. So inductive, the thing is, you're going to start with a set of specific observations and then make a conclusion from it. So start with observations and then you're going to make a conclusion. Start with a specific observation, then make a conclusion. That probably makes better sense. Okay, deductive reasoning, going the opposite way. It's a process of proving a specific conclusion from one or more general statements. A conclusion that is proved to be true by deductive reasoning is called a theorem. So you have a specific conclusion from one or more general statements. Okay, let's look at some pattern problems. So identify a pattern in each list of numbers, then use the pattern to find the next number. So you want to see, is there something that you're adding or subtracting each previous number by, or are you multiplying, or are you doing some exponents? So the first thing I want to look at is, if I want to go from 3 to 12, how much would I need to add? That would be 9. So the way I would come to that conclusion is I'd do like this. Say, okay, this is plus 9. Okay, is the next one also plus 9? Let's subtract 21 from 12. Yeah, it is. So plus 9. So the pattern, 21 to 30, plus 9. 30 to 39, plus 9. So then to get to the next number, I'm going to add 9. 39 plus 9 is 48. Now let's look at the next one. 1, 1. Well, to get from 1 to 1, I would only add 0. 1 to 2, I would add 1. 2 to 3, I would add 1. So that's not really following the same pattern. But what this is doing is 1 plus 1 is 2, right? 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. So to get to that next number, I'm going to add the two previous. So 21 plus 13 is 34. This is the Fibonacci sequence. Go to the next one. Problems with patterns. So use inductive reasoning to predict the next line in the sequence of computations. Then use a calculator or perform the arithmetic by hand to determine whether your conjecture is correct. So let's look at this. So what I see here is all these are being multiplied by 111. And all my outcomes, all of these are ones, all of these are twos, threes, fours. And then the first and last are ones, twos, threes, fours. And in the middle is zeros. So if I do 1,000, let's just make sure this is right. Okay. 202 times 1. Good. Okay. So far, so good. So then, how would I get the next line? This is the first line, and there's all ones. So this is the next line. This is the first, second, third, fourth. So the next one would be 5. So let's see if we can do the same thing. What do you think all of these are going to be? They're going to all be 5s. But let's double check. And it is. So it is true that the previous ones lead to the last one with all the ones on the first line, all the twos on the next time. We're multiplying times 111. So follows the same pattern. All right, let's go to the last page. Problem with patterns. All right, we have exponent problems. Let's study the pattern in these examples. A to the third, and then this hashtag or this number line, that means an operation, a known operation. So a to the third, and then hashtag a squared gives us a to the eighth. A4, and then A3 gives us a to the 14. A2, A4 gives us a to the 10. So we need to select the correct equation. This is actually the same thing as this. So just ignore that and look at these, which one's true. So let's see. How would I have a 3, a 2, and that comes as an 8? So let's see if these work. I could plug in, this is X, this is Y. So this one would be 3 plus 2 plus 4. I'm going to try it out. Well, 3 plus 2 is 5, plus 4 more is 9. That is not right. The next one that says x times y plus 2. So 3 times 2 plus 2. So order of operations says I need to multiply this. 3 times 2 is 6, plus 2 more is 8. That looks good. But I have to check all of them. So I'm going to do whenever I have 4 and 3. So 4 times 3 plus 2 more. So I'm doing the same operation right there, but with these numbers. 4 times 3 plus 2 more. 4 times 3 is 12, plus 2 more is 8 to the 14. So that's good. So our last one. You have a 2 and a 4. So we're going to multiply the x and the y, and then add 2 more. 2 times 4 is 8, plus 2 more. 10. That worked. So this one worked. The next one, 2 times the x plus the y. 2 times that plus the y. That one works because it's 2 times 3 plus 2 more, which is 8. But the next one, 2 times 4 is 8 plus 3. 8 plus 3 is 11. That is not it. This one says you're going to do x plus 2 times y. So x would be 3 plus 2 times 2. 3 plus 2 times 2. That would be 3 plus 4. It's a 7. So that's not it. So B is the correct answer. All right, so more on inductive deductive reasoning because we'll be using that throughout the semester. Examples of deductive reasoning. Examples of deductive reasoning, major premise. So you start with premises and you make a conclusion. All mammals have backbones. Humans are mammals. Conclusion, humans have backbones. Okay, so you have two specific, let's see, what does it say? Let me go back. Two specific statements, right? So these are your statements which lead to a conclusion. And these are true statements, right? That's backed. That's a fact. It's backed by data. Okay? Backed by science, I guess I should say. All right, the next one is an example of inductive reasoning. So you start with data. I tend to catch colds when people around me are sick. So this is an observation. Hypothesis, colds are infectious. So you take the observation leads to an hypothesis. Okay? So that's the difference between inductive and deductive. So inductive is based on observation. Deductive is based on general statements that lead to a conclusion. All right, let's check. It says a statement 3 plus 3 equals 6 serves as a link to the conjecture that the sum of two odd numbers is an odd number. All right, so how does this even relate? Well, it says the sum of two odds is an odd. What do you notice about this? We have an odd and odd. The sum of two odds is an even. So if we have an example that proves it false, proves the conjecture false, that is called a counterexample. Arriving at a specific conclusion from one or more general statements is called, okay, so you come to a conclusion based on general statements. That is deductive reasoning. Arriving at a general conclusion, so this is specific conclusion, this one is general conclusion, based on observations of specific examples. on observation is your inductive. True or false? A theorem cannot have counterexamples. A theorem is true. A conjecture is some kind of hypothesis that sometimes is true, but a theorem, it can't have counterexamples. All right, that is it for 1.1.